That is a real tattoo, by the way. I do have a Perl shebang line tattoo. So I have about 15 years of scars of working in Perl and have worked on it in production quite a bit. So a little bit about me while you're listening to me give this subject is I've been working on this project since 2010. I've been working on the project Nova, what was originally Nova Volume before Cinder actually existed. What got me involved with OpenStack originally was I was working at a company called DreamHost, which created this project you may know called Ceph, and then we spun it out and called it Inktank. So my first contributions to OpenStack was giving a lightning talk at the beta release to talk about Ceph, which nobody has heard about yet at that point. So, and then of course integrating it into Nova Volume, and then we now have Ceph support. So yay. So I work at the OpenStack Foundation currently. I'm a development coordinator. I focus on cross-project initiatives. Issues like the microversioning, for example, is my goal to basically, I've gone from cat herding one project to cat herding all the projects. So I work with basically representatives of each project and making sure that certain services actually happen on the technical side. As well, I was the former PTL for the Cinder project for the Kilo and Liberty release.
There we go.
Whoa. Okay. Cool. All right. Yeah, that's Little John. He's a rapper. Okay, cool. So we spun off the project in Folsom. We came up with a name. You might have saw earlier, New Kids on the Block. That was one of the names that we wanted to call it, but for copyright reasons, I couldn't exactly go with that. So spun off Nova Volume. To be in particular, though, Cinder does not manage object storage. It does not manage file level storage. Just block storage. That's it. Concept of you want persistent storage with your VM. You don't want to go ephemeral route. You want the data to persist as it gets attached from one VM to another. That's what we provide. Cool? So as I said, it's completely independent of the VM itself. My life looks like about this. So just in the Cinder project alone, it was 25,000 patches that we get in a year. So there's only about 12 of us that work in core, and there's about 495 people that actually review, that help us along to make it possible. That's a bunch of rubbish. Here's the Cinder mission statement, though. We implement a service and libraries to provide on-demand self-service access to block storage resources, provide software-defined storage via abstraction, automation on top of various traditional backend block storage devices. The abstraction part, that is a very key point in any sort of OpenStack service, okay? Because it is providing an interface to implementations. Whether you are the user of the cloud, do not care about what is behind. You care about getting some resource readily available to you. So in terms of block storage, if you need volumes, you just want a volume and you want to put data on it. That's it. That's all you care about. Okay. B does something. Okay. So that mission statement, it turns into something like this. What this is an annoying matrix that existed at one point for Cinder. Across each of these rows represents a vendor. You can't really read any of this, and it doesn't really matter because it's irrelevant at this point. Each of these columns represents a feature across for these different vendors. And that continues and goes on. And so what I like to think of what just happened here is a lot of vendors got really, really excited about this thing called OpenStack. And also I like to blame a lot of what happened in the 80s with storage in terms of things like Fiber Channel and other sort of protocols that were introduced. That just makes my life, as I grew up and eventually got into this field, a living hell. But why am I still alive today and why have operators not actually killed me is because of the fact that we have an idea of minimum features, the things that actually describe the block storage service. So in the case of this, we believe in things like you should be able to create a volume, you should be able to delete that volume, you should be able to attach it, you should be able to clone that volume and different sort of operations like that. Very basic. Notice a lot of the things that you get from said vendor on certain shiny checkbox features, not listed up here. I'll get into that later though. So before we get started, what is file level object or file level storage? What is object storage? What is block storage, and so on? So file level storage, you're dealing with network attached storage. In particular, you're usually having something that is going to deal with coherency and across, if you want the idea of multiple writers. You'll have a significant kind of performance differences as well, but satisfy some use cases for some people. So common things that kind of satisfy this, you might have heard of a thing called NFS, maybe. But object level storage, it is slightly different. It implements something very similar to something like Amazon S3. You might have heard of an implementation like Swift that gives you this sort of idea. But in particular, the thing that makes it different is how you're inputting the data. You're using a RESTful interface. You are using actual different request methods in a way of putting data, or you are actually fetching the data, so you're doing GET requests. Okay. In the backend, though, it's just using some sort of file system in the backend, and they like to call things different things. Like, for example, your files are now objects, and your folders are now called containers. All right. So block level storage, I like to think of these just as your simple storage area network or SAN, whatever. But in particular, though, we like to think about it as like a pool of storage. This pool of storage could be either some sort of JBOD or just a bunch of disks, right, on one server, and that is a pool. Or it could be something like a Ceph cluster, which is multiple nodes, racks of nodes, whatever, and that's a pool of data. And for every single request that we get of somebody that wants a volume, we're going to slice out a piece of that, and that's going to be your block to put data on. Now, in particular, though, with block storage, though, there is no such idea as coherency like we saw with the file level storage. So any sort of writes that happen, you should only have one write occurring at that time. Otherwise, you will have multiple writers, and they will clobber each other, and you will end up with some corrupted data. So to kind of show this idea, this is a pool of storage. It has something that is yours right here, and it goes over to your web server, it attaches, and it gets exported, and it looks like that. It's a block, and you're writing data to it. So at a high level of what Cinder looks like, it looks something like this, alongside with the other OpenStack service, Nova. The real thing that people get confused about is they think the data flow happens through Cinder, which is not true at all. In particular, you'll notice with that pink color, that is representing the control plane. And you'll notice that Nova is talking to Cinder, which then Cinder is talking to whatever the storage solution is. In this particular case, it is the reference implementation, which is the Linux Volume Manager. And we will notice that the yellow is representing the actual data flow, where Nova, which has a VM instance that is using this persistent storage from the Linux Volume Manager, is talking directly to each other. Cinder is not in the picture. So here's what the Cinder services look like. There's a Cinder client, there's a RESTful interface, there's a scheduler, which is going to go ahead and pick where exactly that request should be routed. And we have a backup manager, we have a volume manager, and so on. But we'll go into more details on each of these services. So the Cinder client is written in Python. It provides you a command line interface as well as a Python SDK to go ahead and interact with it. So to give an example, here is using the command line interface. I know you can't read this, but this is Cinder create, and then it has -- name, my volume, and 100. What does the 100 mean? It means 100 gigs. So you just requested a 100 gig volume. Again, you don't care that Linux Volume Manager or Ceph or whatever is running back there. As a user, you care about the resource just being given to you so that you could do something with it. It's the whole point with any OpenStack service. So you get back some details about this volume. But if we take into comparison with the Python SDK, this same exact code, again, you can't read this from all the way over there, but trust me that this same exact code does exactly what that command line interface does. So what does this mean? So as an operator or a user, I can request volumes from the command line interface, or I could write scripts around to actually automate creating my own volumes in an OpenStack cloud. So this exact code will perform that same command. So the Cinder RESTful API basically gives you exactly those minimum features that I spoke about earlier. You could do exactly all these things. And the important detail is that the implementations do not dictate what the API is. That is a very important thing, because if they're inconsistent, then you can't actually guarantee to the user that any said request is going to work. So it is our job from the OpenStack standpoint to actually gate on that and to request that every single implementation works with the minimum features. How we guarantee that, I will get to later. Here's an example of the RESTful interface. Again, you see this code, which is fetching, going ahead and connecting to the Cinder client. Bear with me if you're not familiar with Python code and the fact that you can't read this. But also, we are doing a volume create, and we're specifying the name of the volume and 100 gigs. Here's what that web request looks like. If you were to actually send a raw post request to Cinder for volumes, you would specify exactly volume, and the size is 100, and the display name, which is the name of the volume, my volume. And the response you would get back is exactly what the command line interface would get you. How many people just learned something about OpenStack? Anyone? Okay, Mark and Megan and Rocky. Great. I feel good. So the scheduler. So the idea with the scheduler is to actually route the requests based on what the user actually wants. So the idea with Cinder is that you could deploy multiple multiple vendors or any sort of block storage solution that you want. Okay, and within those different solutions, you may be concerned with, well, how exactly do I set up things like QoS? How do I make any of those guarantees? How do I set up any sort of concept of replication? So every single backend has some sort of concept of a capability. Okay, and we actually do also standardize on those capabilities as well. But not every single backend can actually provide all those capabilities all at the same time. So, but from the end user's perspective, we want to be able to say, well, I want your really fast, fastest storage solution, which may have a backend solution that's using SSDs. I also want to, be able to request volumes that are using your slower option because it's cheaper, and I want to do archival things with it, and those might be on spinning disks. So how do you exactly do that? It's with the scheduler. And the scheduler is going to determine, based on the request, which backend that it actually goes to, or which pool in that backend that it actually goes to. It could be all set on based on what type of hardware and so on that you're using. So the way that we do this, though, is with the concept of volume types. Volume types are tiering. From the user's perspective, they don't know that the QoS. So to give an example, one of my favorite things with vendors is the fact that we have, for QoS to even define it, for one vendor, it might mean on and off. For another vendor, it might be bronze, silver, gold. And for another vendor, it might be actually setting the min and max IOPS. Okay? But imagine if you go from one OpenStack public cloud to the other, and you have to know, based on what vendor they're using, how to set the QoS settings. That's a total nightmare. So instead, the only thing that the user will actually see is these kind of tiers. So here's an example of a user going through the dashboard, OpenStack Horizon, and being able to specify their volume name, description, and the actual type that it is. And it's just tiers. So this allows the operator to describe as much or as little as they want about that volume type of how that volume request will be routed to which backend, which is what the scheduler eventually will pick out. So the volume manager itself is all the smarts of knowing how to create volumes, delete volumes, and so on across the different vendors. And by the way, the Cinder project today has by far the most plugins than any other OpenStack project today. It has 75 drivers as I counted before I came up here.
Certified.
So, and in particular, so this has the smarts to talk to each of those backends based on the API that we specified. So the backup manager is giving you sort of the idea to any of those volumes that you have in your backend solution to perform backups to an object storage layer. We support, of course, Swift. We also support the Ceph Rados gateway. We also support just having a basic POSIX file system on the other side, Google Cloud Storage, and the other ones that are listed here. The idea here, though, is that you have another site that has one of these solutions, obviously Google Cloud Storage being out of your data center, but if you had Swift deployed, for example, in another data center and you wanted to back up that data, and maybe it's also cheaper hardware on that because you're not going to be reading off of it too often, well, you can have a volume be backed up to that actual solution offsite. So very quickly, the current volume drivers, it's a huge list. Oh, by the way, my slides are already posted on the Meetup site, so go take a look at it. They're all posted there. I'm kind of going to go through. But all these volume drivers, as I was going to surprise you all with, is that they have CI testing, which I think is by far the thing that has not really existed inside of OpenStack for quite some time. Yes. So in order to get inside of the OpenStack project for block storage, you are required to have a form of CI testing. That means you have on-site in your lab for your company, you are pulling down OpenStack patches and you are actually testing those patches against an actual backend solution that you are selling. So, and the tests that are ran are the same exact tests that run upstream to verify that your integration inside of OpenStack actually works. It's the same test that we perform upstream against the Linux Volume Manager. So here's an idea of an OpenStack patch today. This is one that's in review, but let's zoom in. Right there, you'll see solutions like Dell, Pure, NetApp. Those are all being tested in their lab for that particular patch, verifying whether or not that patch actually breaks their integration inside of OpenStack. So, Liberty. Liberty, we got the idea of nested quotas. The idea with nested quotas is that you can go ahead and have a hierarchy of projects that you want to set quotas for them. So this is all based off of the count of volumes, all based on the count of gigabytes, and so on. The specification is linked there. Again, my slides are on the Meetup site, so please go and take a closer look at that. I'm trying to speed along. So the generic image caching solution, we wanted the ability for every single volume that you would be spinning up that it actually is coming from the Glance image store, for example. You may have images that get downloaded quite often. Okay, so maybe you have like a Ubuntu 14.04 image that gets downloaded constantly. The problem with the current design inside of with Cinder and Glance is that that image, all the data has to actually come over from wherever Glance is storing the image over to where the backend solution for Cinder is. So that downloads over the network, you know, piece by piece. But instead, this gives a generic solution across all 70 drivers to go ahead and have the images stored in a caching solution so that the storage solutions can actually do a smart copy on write of that image. And seriously, it's like that. And this is a generic solution that we came across for all drivers. seriously, read the specification, find me if you want more details on it. I'm kind of speed along, sorry. Mitaka, we're looking at disaster recovery right now. The idea to be able to fail over from one backend to another backend, and Cinder can move you from backend A to backend B. Don't have enough time to go over it, unfortunately. Cinder active, having the idea to have a volume manager, multiple volume managers talking to the same backend solution, giving you an HA case, so if any of the volume managers go down, your requests will still be served. The micro API versioning, the idea that you can have an application ask the server what is currently possible today, what are the versions that you support? And based on what you get back, if your application, for example, only supports V2, and the server says, I could support V2, V1, and V3, you could say, okay, hi, I'm an application, I'm gonna send a request off, and this is in V2 format. So please honor it. Farewell.